Students, in this session we are going to discuss specular reflection and Phong model. First, we describe what is an specular reflection. In addition to diffuse reflection, light sources create highlights or bright spot called specular reflection. This specular reflection is more pronounced on shiny surfaces. It means when a reflection in a particular direction, then this reflection is called specular reflection. When we look at illuminated shiny surfaces such as polished metal, an apple or a person's forehead, we see a highlight or bright spot at certain viewing direction. This whole phenomenon is called specular reflection. So the phenomenon of reflection of incident light in a concentrated region around the specular reflection angle is called specular reflection. Now इस डायग्राम में अगर हम देखें, this is our surface, this is our viewing direction, this is our light source direction, this is our normal vector to surface, then this is our specular reflection, and this phi is called angle of incidence between reflection vector and the viewing direction vector. To simplify the specular reflection, we use Phong model because we know that shiny surfaces have a narrow specular reflection range and dull surfaces have a wider reflection range. इसका मतलब कि जो हमारे shiny surfaces होते हैं उनका जो reflection होता है वो थोड़ा कम होता है, लेकिन जो हमारे dull faces होते हैं उनका reflection थोड़ा ज़्यादा होता है. क्यों? क्योंकि shiny surfaces हमारे कुछ light को absorb करते हैं. To calculate the specular reflection formula, we are going to use a Phong model which is developed by Phong Tom. According to Phong model, we can set the intensity of specular reflection proportional to cos ns phi, where angle phi can be assigned values in the range 0 to 90 degree. It means 0 to 1, and the value assigned to specular reflection parameter ns is determined by the type of surfaces that we want to display. It means अगर कोई हम shiny surface यूज़ कर रहे हैं तो उसकी जो वैल्यू होगी ns की वो लार्ज होगी. अगर हम डल सरफेस यूज़ कर रहे हैं तो उसकी जो वैल्यू होगी ns की वो कम होगी. लेकिन जैसा कि हम जानते हैं कि जो शाइनी सरफेस है उनका जो रिफ्लेक्शन होता है वो कम होता है, लेकिन डल सरफेस का जो रिफ्लेक्शन होता है वो ज़्यादा होता है. To generate the specular reflection formula, we can use a specular reflection coefficient w theta for each surfaces. So I spec is equal to w theta il cos ns phi, where cos ns phi is the angle of incidence, il is the intensity of light, and w theta is specular reflection coefficient. The intensity of specular reflection depends on the material properties of the surfaces and the angle of incidence. So here we can clearly identify that w theta is a material specular reflection coefficient which ranges from 0 to 1, il intensity of the light, theta phi is equal to angle between viewing vector and the specular reflection vector. If the value of w theta is 0, it means cos phi is equal to 1, then we can generate a more reflection, specular reflection. If value is 90 degree, then cos 90 is equal to 0, then we generate less specular reflection. Now we can change a specular reflection coefficient w theta, this coefficient w theta, by a specular reflection coefficient ks. We then simply set ks equal to some value in the range 0 to 1 for each surfaces. Since v and r the unit vectors, as we know that v and r unit vectors in the viewing and specular reflection direction, we can calculate the value of cos phi with the dot product v and r. So we can replace cos n as cos phi in terms v dot r. V is a viewing direction vector and r is reflection vector. Now we can generate this formula in terms of v vector in direction of light and r reflection vector. So this is our, ये हमारा एक सरफेस है, ये हमारा रिफ्लेक्शन वेक्टर है और ये हमारा वेक्टर है इन डायरेक्शन ऑफ लाइट. दिस इज अवर नॉर्मल वेक्टर टू सरफेस. दिस इज एंगल ऑफ इंसिडेंस बिटवीन this vector and this vector, and this is angle between this vector and this vector. The law of reflection states that the angle between the incoming ray and the normal vector theta 1 equals to the angle between the outgoing ray and the normal vector and theta 2. Both angles are equal. It means theta 1 is equal to theta 2. Now total angle is theta 1 plus theta 2, which is replaced by theta 3. So v dot r is equal to cos theta 1 plus theta 2. As we know that theta 1 is equal to theta 2, then cos, replace theta 1 is equal to theta 2 is equal to theta 1, then cos 2 theta 1 by the trigonometric formula. Cos 2 theta 1 is equal to 2 cos square theta 1 minus 1, because theta 1 is the dot product between v dot n. हम क्या करेंगे, cos स्क्वायर थीटा 1 को रिप्लेस करेंगे v डॉट n से, तो क्या बन जाएगा 2 इंटू वी डॉट एन स्क्वायर माइनस 1. हम इस 1 को रिप्लेस कर सकते हैं v डॉट v से, बिकॉज जो वेक्टर का डॉट प्रोडक्ट होता है वो इक्वल होता है 1 के. देन 2 डॉट v डॉट n माइनस v डॉट v. अगर इस पूरे इक्वेशन में से v को कॉमन ले लें तो हमारे पास क्या बचेगा, टू वी डॉट एन स्क्वायर माइनस v. इस v से ये v कैंसिल, तो क्या बचा, r इज इक्वल टू 2vn डॉट n माइनस v. v क्या है हमारा, वेक्टर टू द वेक्टर इन डायरेक्शन टू द लाइट सोर्स, और n क्या है हमारा, वेक्टर नॉर्मल वेक्टर टू द सरफेस. तो हम क्या कर सकते हैं, रिफ्लेक्शन वेक्टर को जनरेट कर सकते हैं इन टर्म्स ऑफ वेक्टर इन द डायरेक्शन ऑफ लाइट सोर्स एंड नॉर्मल वेक्टर. Now we can simplify specular reflection and Phong model by using a middle halfway vector h. A somewhat simplified Phong model is obtained by using the halfway vector h between L and V. This is our vector in the light direction and this is our viewing direction vector. We can generate a halfway vector h. So if we replace v dot r, this is vector in viewing direction, reflection vector, in the Phong model with the dot product of n dot h. N is normal vector to the surface and h is halfway vector. So where h is equal to L plus V upon mod of L plus V. L is vector in the direction of light source, V is viewing direction vector upon mod of L plus V. Now we can combine diffuse and specular reflection with multiple light source. Suppose we are using a single point light source, then I total intensity of light is equal to I diffusion reflection plus I specular reflection, which is equal to Ka Ia, where K is a reflectance constant, Ia intensity of light, plus Kd IL n dot L plus Ks IL n dot H ns, where H is halfway vector, n is normal vector, Ks is specular reflection coefficient, K is diffusion reflection coefficient, I is intensity of light, n is normal vector, and L is vector to the light source. If multiple light sources are there, then we can generate this formula. So this is all about Phong model. Now Warn model, it is another model which is simplify the Phong model. The Warn model provides a method for simulating studio lighting effects by controlling light intensity in different direction. Means जब हम किसी फोटोग्राफर के पास पासपोर्ट साइज फोटो खिंचवाने जाते हैं तो क्या करता है, डिफरेंट एंगल से लाइट को फोकस करता है, यानी डिफरेंट इंटेंसिटीज की लाइट को फोकस करता है, जिससे हमें एक मल्टीपल इफेक्ट जनरेट होता है, जिससे हमें अपनी पिक्चर अच्छी दिखाई देती है। तो उस इफेक्ट को जनरेट करने के लिए भी इसका यूज करते हैं, इस वॉर्ड मॉडल का यूज करते हैं। इंटेंसिटी इन डिफरेंट डायरेक्शन इज कंट्रोल्ड बाय सिलेक्टिंग वैल्यूज फॉर द Phong exponent. In addition, light controls such as barn doors and spotlighting used by studio photographers can be simulated in one model. So this is all about Phong model and specular reflection. Thanks.